So let's review these. Draw an example for each type of ankle pair, then explain their relationship. Well, we've already drawn these ones. This is complementary because if we add these two angles together, this one and this one right here, then yes, it would create a 90-degree ankle right here. And then over here, supplementary because if I add this one, this ankle with this ankle right here, it gives us this straight line right here, which is supplementary. It's 180 degrees. And then on these vertical ankles, this ankle would be the same as that one, and also this one would be the same as this one because they are verticalness. Adjacent ankles also, we've got this ankle and this ankle, which are adjacent even if they are not congruent or the same. So those are examples of each type. Now we got to look at these and determine if they are complementary, supplementary, or neither. So 5, if I took these two ankles together, if I put them together, what type of relationship would I have? Comp. Very good. This one would be comp. 6, this one, number 6. We have two ankles, and if I add these together, 80 plus 10, we get 90 degrees. So what type of relationship is that? Complementary. All right, what about number 7? This one, we got two ankles, 125. If I combine these, then I get 0, 1, carry it, 180 degrees, which is what type of relationship? Sub.
Dog.
So on number 8, let's add these two together. We got a 37-degree ankle and a 53-degree ankle. When we combine these, 0, carry the 1, 90 degrees, which is?
That is
comp.
What's a comp?
That means that it is complementary ankles, meaning they add up to 90 degrees. What about this next one, 110 plus 70? Yeah, very good. That's 180 degrees, which is what's up?
Sup is 180, comp is only 90.
Find the measure of the identified ankle, which is right here. This one is verticalness with this other 70-degree ankle, so this one is also 70 degree. Verticalness makes it usually pretty easy like that. 11, this one is extremely difficult because the two are vertical. Through the vertice, bam. Now we know it's 33 degrees. Look at all that work. That was hard. That was rough. So are the ankles in number 10 adjacent or verticalness? These ones are vertical, and we did already explain that. So vert. Are the ankles in number 11 adjacent or vert? Very good. These ones are vert. Bam. All right, yeah, so let's, if we identify this, these are adjacent. So if we combine these two, what type of relationship is it? These ones are adjacent and also sub, right? So that means that we got to take our 180-degree ankle, which is the straight line, and we're going to subtract that 123 to figure out the measure of that other ankle, right here. So what do we get? A 7 and a 5, 57?
Yeah.
57 degree would be this missing ankle right here. In 10 through 13 above, the adjacent ankle pairs are also examples of sup ankles. Are adjacent ankles always sup? No. No, they are not, because sometimes we'll get some kind of ankle like these, which gets split up by this one. See, now these two may not be sup. Bam. 13 right here. The ankle that it wants us to use is this one. And it's with that 55-degree ankle. So these two, given the choices, adjacent or vertical, these two are adjacent. We could say that they are also supplementary. But let's go ahead and find the measure of that ankle. So we got, this whole thing would be 180 degrees right now. Well, we used up, out of the 180, we can see we got the 55. So we subtracted to find the measure of this ankle, which would be 5 and a 7 and a 2, 125. All right, let's use angle relationship, complementary, supplementary, or vertical to write a simple equation to find the missing angle. For example, 180 equals 50 plus x. We'll do these a little bit different. All right. All right, so these two ankles, the one in red and then in light lavender, is those are complementary because it shows the 90-degree angle right here. So if I add the two,
25.
so if I take the 65er and I added this to the ankle M, then I would get 90 degrees
M equals
because of their complementariness. Well, if that is the case, let us solve these. So I got 90 minus 65er,
25.
which would be 25 degrees. So this ankle is 25 degrees. These two are supplementariness, so they should add up to 180. So the equation will be 180 should equal the two ankles added together, 39 degrees, plus that big ankle M. So to find that measure, we're going to take 180 and subtract the 39er, and we get 141.
Because
41
141
degrees.
plus 30.
All right, this one, it also wants an equation radical. And we can see that these two ankles make up a straight line, so they should add up to 180. And that would be the same as taking the 95-degree ankle and adding it to the m degrees, which is just a variable or unknown. So to solve this, we're going to take the 180 and subtract 95, which would be 85 degrees. So this ankle radical is 85 degrees. Bam. So this one is a complementary relationship because it showed us the right ankle radical. So the equation, we could also write it like this if we wanted. We can do 180, not 180. This one would be 90 because it's complementary minus the 33 degrees will tell us what m is, so that can be the equation. And 90 minus 33 is 57 degree. Bam. Write equations for A, B, and C below. For 19 through 25, draw a model if we need to. And that will hopefully help us to find the measures of the indicated ankles. Here we go. Yep, so for ankle A, which is at these, that's a sup relationship with 73. So I got 180 degrees minus the 73 would give us that missing ankle measure, which appears to be 107 degrees. What about B? This one's verticalness, radical. So it is simply 73 degrees. Also, C is vertical with A, so we know that's also 170 degrees, 107 degrees. And we don't really need an equation for these two. We just need to know the relationship for both of them. Two angles are complementary. One ankle is 5 times the measure of the other ankle. What is the measure of the two? So let's do this one where it's complementary, not supplementary. Okay. So for these, and we need, it's not perfect, but that's close to 90 degrees. So this would be complementary radical, and this needs to be split up because the two ankles will become complementary. So we're going to give ourselves another line, radical. Now we got these two ankles, this one and this one, which combine to give us 90 degrees. But one of these is 5 times the other, so I'm going to say that this one is x, and this one is 5 times that x. I'm using x because we don't know the measure of that one. This one works the same like we did it with supplementariness, just got to remember it's complementary. So if I take my x and I add it to these 5 x's right here, then I would get 90 degrees, which is very different. And when I combine the two ankles, 1x plus the 5x would give us 6x's equals 90 degrees. And then dividing both sides by 6 tells us that x is 15. 15 degrees. So one ankle is 15 degrees. The other one's is 5 times that. Or you could subtract it from 90, and you would get the 5x, which would be 75 degrees. Bam. There we go. Yeah, so on this one, the complement is 90 degrees, so the two will add up to 90. One of them is 28. Let's subtract that out. Bam, 62 degree for this complementary ankle to 28 degree. All right, two ankles are supplementary, meaning they add up to 180. So let's draw a figure of this and see if it helps us out. So there's this supplementary ankle, but it's been split up into two ankles. One is 2 times the measure of the other. So this one, we're going to say is x. This other one, we're going to say is 2 times that. And we don't know that value yet, but we're going to find out. What are the measures of the two ankles? Well, these two add up to 180. So in other words, 180 will be the same as the smaller ankle, and then the one that's twice its size. Now really that's a 1x, meaning if I combine them, I've got 3 of those ankles, equaling 180 degrees. Now if I divide both sides by 3, we can see the smaller ankle would be 60 degrees. So if this one is 60 degrees, the other one is 2 times that, 120 degrees. So that's our two answers right here. 60 degree and 120 degree. Find the measure of an ankle vertical to a 56 degree ankle. That would also be 56 degrees because it's vertical. Find the measure of an ankle whose supplement is 9 degrees. Well, if it's supplement, then they add up to 180. So I'm going to take 180 and subtract those 9 degrees. And that would be 171 degrees would be the measure of that missing ankle. Number 20, find the measure of an ankle whose supplement is 89 degrees.
99.
So supplement means that they add up to 180 degrees. So I'm going to take 180 and subtract that 89 degrees because they are supplementary, and we get 91 degrees. Bam. All right, Juan has twice as much money as Lisett. If they have $180 together, how much does Juan have? Okay. Well, they gave us the equation. Oh, they did this example for us right here. So we can see Lisett had 1, Juan had twice as much. So if we double that, we get 3 x's. Divide both sides by 3, and we see x is 60, so Juan would have twice that at $120. One ankle is 25 degrees bigger than another ankle. The two ankles are supplementary, so it's 180 degrees. What is the measure of the two ankles? Okay. So let's draw a picture of this and see if it helps. So there's my straight ankle, and we're going to split this up, something like this. So we're going to say that this is the smaller ankle, and the bigger one is the smaller one, but we're going to add 25 degrees to that. So if we take this, the small ankle, and then the big one, x plus 25, if we add these two together, then we should get a straight ankle at 180 degrees. Now if we look back, this is 1x and that's 1x, so if I combine them, I got 2x. And to solve for the x's, just like we did in Unit 3, I think, we're going to subtract 25 from both sides. Then I got the 2x's equal 155. And then we'll divide both sides by 2. And what is that?
77.5.
77.5. Now that's a small angle, 77.5 degrees.
And just add
Well, yeah, if the other one's 25 more than that, then we'll just add 25 to it, which is
102.5
degrees.